Well, good morning, ladies and gentlemen. Welcome to the Woodrow Wilson Center. My name is Jeff DeBelko. I direct our Environmental Change and Security Program. And it is my great pleasure to welcome back Jim Fleming to the Wilson Center, who had time here as a public policy scholar, working on a book that we're talking about today. Today's session is entitled Fixing the Sky, The Checkered History of Weather and Climate Control, a book I hope you will pick up outside, maybe even have Jim sign it. We are thrilled here at the Wilson Center to have scholars like Jim Fleming come and work on issues that, as a historian, obviously have great historical importance, but as we will hear today, tremendous importance for current policy discussions. James Fleming is a historian of science and technology, professor of science, technology, and society at Colby College in Maine. His teaching bridges the sciences and the humanities, and his research involves the history of the geophysical sciences, especially meteorology and climate change. So Jim was elected as a fellow AAAS in pioneering studies on the history of meteorology and climate change. I think for us, most fortunately, he was the AAAS Roger Revelle Fellowship in Global Stewardship that allowed him to sit at the Wilson Center between 2006 and 2007. So Jim's book, Fixing the Sky, The Checkered History of Weather and Climate Control, is, as you will hear, a book that sets these efforts in a historical context, but as I mentioned, gives us, I think, a critical perspective and an understanding of these prior attempts to control weather, control climate, in the context now as we're grappling with climate change and the appeal of geoengineering, making these big changes, trying to control these big geophysical processes, more and more tempting in the political realm. And so we are so pleased to have him make this contribution so we can understand where we've been. A word about the Wilson Center. It's the formal memorial to Woodrow Wilson, our 28th president. We were created by Congress in 1968 as a formal memorial, a living memorial, to where the worlds of scholarship and the worlds of policy can come together and learn from one another. And our environmental change and security program is a little younger. We've been around since 1994. But as we will see in today's discussion, trying to bring together some worlds that don't always have a natural place to come together and talk, the worlds of environment and science and the worlds of foreign policy and security policy. So we are indebted to Jim for coming and sharing his insights with us today. And I want to hand the floor over to him.
Thanks, Jeff. Thank you. Thanks, Jeff. It really is a pleasure to be back and to be invited back. And certainly the conception of the book was here. I worked on weather control as a young pup flying around in storms as an atmospheric scientist, and I realized it was too dangerous to do for the rest of my life, especially when we clipped off some treetops. And I moved into history as a further way of engaging with the atmosphere, in which you can actually be a slow learner and work at a slower pace than the atmospheric sciences, and began writing articles a long time ago about the history of weather control, about the private limits of support or a corporation like General Electric in supporting atmospheric research in the 1940s. And I had let it sit. I had done other things, but when I came down here, my proposal with the Revelle Fellowship and then the Wilson Center Public Policy Scholarship was to look at the climate, the budding, what do we do about climate change issue? And that brought the issue of what I think was doing too much rather than doing too little. It was the end of the Bush administration, and a lot of the talk was about doing nothing or being skeptical about everything. And the other alternative that was bubbling up was doing what I consider to be outrageous experiments of building space mirrors at a mere $2 trillion with nanotechnologies that didn't exist, or hanging hoses on high-altitude aerial vehicles to spew sulfates in the stratosphere, and the vehicles didn't exist, or to shoot naval cannon with the shells full of sulfates into the stratosphere, or perhaps turn the blue ocean soupy green with iron fertilization. And the more I heard about these things, and having been a geoscientist myself, and my first career was an atmospheric scientist, and then desiring to connect with history. And so the history, when I got my book on August 15th, I got my own personal copy, and I thought, this is connecting with public policy. We had had so many discussions about whether we should fade into the past and just end when the archival record ends and just be happy to scurry around in the National Archives. And with serious historical scholars that were making these decisions, and we decided that, or I decided that what I wanted to do is bring my history to bear on current public policy issues. So it's so much desire that it's taken a little bit extra time, but I also have a blog called Atmosphere, which is following up on the Fixing the Sky, because on Monday in the Washington Post, there's something about climate engineering. It was, I don't have the citation with me. Last week in Slate, there's 8 articles with my own subversive article in there as well. And we've had conferences. Often I've been the only historian at a conference, and we had met for a week with nothing but technical fixes and sweet proposals about how we might do this. Well, we could tip the Earth's axis, or we could put little shock absorbers, nano shock absorbers on the CO2 bonds, or, you know, the really, really crazy things, I want to say. And I was often the only historian, maybe with a couple of ethicist buddies, where we had to weasel our way onto the program and try to find a seat at the table. The policy table was full of technocrats, white, Western, male, middle-class technocrats. And I'm a white, Western, male, middle-class, non-technocrat. So it doesn't, visually it's not so stunning, but we were trying, my mantra was international, intergenerational, interdisciplinary, fully interdisciplinary, not just an oceanographer and an atmospheric scientist or an ex-Lawrence Livermore type and a Harvard type policymaker. So the economists were there, some sociologists were there, but the real historically informed humanities were not. And then we got a little bit of a piece at the table. So I'm standing there with my book and thinking, this is beginning to articulate. It's only the very beginning, but instead of focusing, certainly the details some of the details are in the book, but I want to encourage anybody with those aspirations to think about it, not necessarily do it, but think about how you might bring more light than heat to the current debates about public policy by providing a sense of the past, mobilizing a bit of perspective on some of these issues. And I guess I have an epigraph in there about when facing unprecedented challenges, it's good to seek some historical precedents. Or the other way to put it is the other way to put it is everything's unprecedented if you don't read history. Now, on to the topic at hand. During that time, in the fall of 2006, I was invited to go to NASA Ames, just south of San Francisco, to a meeting called Managing Solar Radiation. And again, I was the only historian, and at that point, when I came back, I remember cartooning and photoshopping together a little impression of the meeting. Remember, it was managing solar radiation, cutting off sunbeams. And I came back saying, this is what we were talking about. World's too hot, we can cool it. We have a technological fix for CO2 global warming, which is in cutting off shortwave solar radiation. The inspiration behind the meeting really was Edward Teller, father of the H-bomb, as I learned here, father of sprawl. I think I learned that right in this room. And father of peaceful uses of nuclear weapons. His final paper, The Planet Needs a Sunscreen, was Edward Teller's last paper with his protege, Lowell Wood, next to him. And so Wood was at the meeting along with a whole plethora of other technocrats thinking in quasi-military terms, using either leftover or futuristic hardware on how to use that to basically shoot things up into the sky to manage solar. And what I can't help but tell you, one of the anecdotes, it was the fall of '06, and the room was a little warm. We had the doors open, and the meeting manager came by and said, on mic, she said, "I'm very sorry, we're having some trouble managing the temperature of the room." And here we were trying to manage the planet. It was ironic. We laughed. But one of my friends I met at the meeting, who was a very ethical climate modeler, Alan Robach from Rutgers, was at the meeting. And he had about a 17-point list of why climate engineering was bad. And so a lot of it came out of his own sensibilities as a respected atmospheric scientist, and also out of his models. Because one of the big questions that we discussed is who has the moral right to fix the sky? If an engineer wants to fix a bridge or an engineer wants to build a bridge, they'll need to go to the city planners and get a permit and be very careful with the negotiations and safety issues. Who has the moral right to fix the sky? Where would the global thermostat be? Do you think it would be in Indonesia? Do you think it would be at Lawrence Livermore? Do you think it would be in China maybe in the future? Or could a nation set up a thermostat against the will of another nation and have varying Asian temperatures or something? We already have them, but we have them naturally. What if we had them artificially? And you know, the Olympics were coming up at that time, and they had 30,000 Chinese artillerists shooting chemicals at the clouds to keep either the venues clear or to get the rain done on the weekend before the Olympics started. And they're still doing this kind of stuff. So now there's regional tensions in China because imagine rain comes across the country. Some places get hit, some places are missed, there's intermittent showers. But now every intermittent shower is seen as a managed event where you took my rain away from my farmland. And so as soon as you start managing the sky, you start fighting about it. Could it reduce incentives to mitigate? Could there be unknown side effects? Robock's model showed that they were trying to emulate Mount Pinatubo, which cooled off the planet about a degree from 1991, its eruption through about 1993. So they said, well, let's make an artificial volcano. We'll emulate Pinatubo. But unfortunately, Pinatubo is correlated at least, with massive droughts in the Nile River. Robock's model showed that these sulfate clouds wouldn't stay put, but they could cause the shutdown of the Indian monsoon. How would you like to be responsible for an experiment going awry that shuts down the Indian monsoon? It also showed a massive depletion of ozone for 93, the greatest on record, because the sulfates are up there. And we know that these kind of chemicals are not very friendly with ozone molecules. So there's unknown side effects, or there's actually predictable side effects, but where they're going to happen is unpredictable. One of the themes in my book is how all these things are commercialized and also militarized, and what if countries would do it unilaterally. So those themes of commercial charlatans and military people getting a little bit too enthusiastic about their high technologies are in the book. And does it violate existing treaties? There's an article, there's also the Slate magazine set of articles that includes an analysis of NMOD. We did an analysis in our book, too, about NMOD, the Environmental Modification Treaty of the UN in 1978, which has been revisited twice since and could be revisited again if large-scale environmental modification were to get more serious, if there's deployment of geoengineering techniques. But one of my big ones here, and we don't have the team assembled yet to fully address it, is the question of altering fundamental human relationships to the sky. I hinted at it by saying the Chinese were getting antsy about who's getting their rain that their artillerists are bringing to them. And so nature is no longer a player in that. It's all fixed. Maybe West Texas is all fixed already because everybody's cloud seeding in West Texas. But will our human attitudes to the sky be fundamentally changed? I'll give you a historical example in just a second. To set up the story, I have to tell you that one of my colleagues, while I was here at the Wilson Center, Kerry Emanuel, is a great meteorologist up at MIT. He's the fellow that talked about enhanced hurricane strengths being connected with climate warming. And one of his theories was that you'll get bigger, stronger hurricanes. Well, he wrote an article in Boston Review in 2006, and I showed it to my research assistant, Meta Olwig. And she was not a meteorologist, but it argued that we have to learn so much and model so much the climate that we can take up Phaeton's reins and control climate. The story of Phaeton could be familiar to most of you. He's the son of Helios, the sun god. He asks his dad for a favor, and his dad hesitantly says, okay, one favor, and the son says, I want to drive your sun chariot. I want to manage solar radiation. This is a Greek myth of managing solar. And Phaeton is a lightweight. The horses know he's a lightweight, and they run out of control all over the zodiac, all over the sky. But Helios had said, stay on the middle path and hold tight the reins, son. And Phaeton didn't hold tight and ended up burning up part of the planet, and Zeus had to shoot him out of the sky. So this is an image of Phaeton as one of the four disgracers. He's having a bad day. The chariots are blown apart. The horses are falling from the sky. And he's one of these 4 disgracers. Emmanuel, my colleague at MIT, said, take up Phaeton's reins. Try to control the climate. I think what he meant to write was try to control your CO2 emissions or manage your carbon budget or something more reasonable. But try to control climate was the message, using Phaeton as the image. So I couldn't help but use this as a framing device for the book. And I have to say that, so it's framed not only in a historical narrative, which for me begins in about the 1830s, but it's framed in classical myth, in non-Western myth. The rainmaker in Indian tribes is the brave who's on duty when it rains. The rain finds the rainmaker. Rain kings and rain queens are part of a lot of traditional cultures, and there's some aspects of that in my writing in the book. So I wanted to say it's an ancient thing to think about fixing the sky or to controlling Mother Nature, but it's also an act of hubris, and it's an act of overreaching. It's an act of a disgracer. And having set it up in a very serious way, then, I couldn't help but find a number of very tragic comic examples of charlatans and relatively pathological but sincere scientists going way beyond what their theories might predict. So the book is, most histories of science are heroic, standing on the shoulders of giants or seeing further than had ever been seen before, or lone inventor, the genius narrative. Most environmental writing is somewhat tragic, somewhat declensionist. The things are not as pristine as they were. But this is a full tragic comedy because of the characters in there, the kind of Rube Goldberg devices and attempts to take a little bit of theory and make a whole lot of money out of it, or a little bit of theory and weaponize it, or going beyond what your normal next step would be. And so in science, there's UPS, or UPC, as the code goes, understanding, prediction, and control. And people jump to control way too quickly, thinking they can control a process. How many times have you heard about identifying a gene, but now it's the cure for blank? That's a little bit of a jump to go from promise to hype so quickly. And when you're doing it with your own planet, it's incredibly important. If you're doing it with your body, you might take that experimental treatment and sign off on the release for the physician to experiment with you, but you can't sign off for my planet, and I can't sign off for yours. So this has to become an international negotiation, intergenerational, interdisciplinary. The first historical example I have is someone I've worked on for a long time, James Espy, who was a very competent first federal national meteorologist funded by the U.S. Army Medical Corps. And he had federal funding, worked at the Smithsonian, and he had the convective theory that heated air rises and rising air cools, and cooling air condenses its moisture and the rains come. That's true today. But he also thought if you burned the whole Appalachian Mountains forested part, you would enhance the rainfall. So he wanted to slice large woodlots and had let them sit dormant till they dried. And then every Sunday night, he proposed lighting fires from all the way up from Maine down through Georgia. The population lives to the east of that. And he thought that these rising columns of hot air would make it more convective and would trigger rains that would not only solve any sense of drought, but they would also clear the air of miasmas and all kinds of nasty things. So he proposed for health and for regulation of industry and farming that he should get paid for every rain he caused. And so here's a wonderful, theoretical meteorologist, the first of our nation, and he gets pilloried in the press, and he's just considered to be quite a kook who'd gone way overboard. There's a lot of stories about that. I tell some of them in the book. But the story I like is that Eliza Leslie, the same year he wrote his book, Philosophy of Storms, wrote a ladies' magazine article of 100 years in the future. She said, what if Espy's technique really worked and Espy's great-great-grandnephew in Philadelphia could control the weather? Well, he would open a shop and have people petitioning. The washerwomen and the alfalfa farmers wanted dry weather that weekend. The umbrella makers, the cabbies, they wanted it to rain. So they get up to, the voting starts during the week, and they get to 50-50 by Friday afternoon. And a 51st, the 101st lady runs into the office. She's a matron demanding that he make it rain because her country bumpkin cousins were coming to town, and she needed the roads muddy to keep them out. So here's Philadelphia, 1942, visionary, still dirt roads. And she actually swings the rainmaker, and he pulls the lever to rain, and the rains come. And she says, Leslie says, so everyone who would have accepted the rainy weekend with a shrug was now suspicious of somebody else had got their way. And it's very much like that Chinese story today, where there are internecine struggles between keeping and taking the rain away from others. And I experienced this personally, not Leslie, but I was flying in a glider in 1973. And we were only being pulled into the updrafts without a motor. We were just studying big clouds. But one night at the motel near the hangar, the police came, and we were a little worried what's going on, and nothing about us per se, but they said, you better come down to the airport because somebody had thrown a Molotov cocktail through the window of our hangar and burned up the National Center for Atmospheric Science glider. The farm community, maybe Farm Boy, we don't know who did it yet, but they thought we were stealing their sky water. So these emotions are real. There's meteorologists have been shot at, and there has been this kind of vandalism and violence. And I think Leslie caught the notion of social tension in the very first essay I know in early America about this. I'm going to say that there's a lot of other stories. I tell a lot of them. A lot of them are quite entertaining and bringing a huge leap from that kind of scenario to controlling hurricanes. This is Hurricane King, which one of my protagonists, the Nobel laureate Irving Langmuir, tries to control with dry ice. Turns out if you put dry ice into a cloud, it does make it a lot colder, and it can bring ice into the cloud, and it could possibly make it rain. It could dissipate the cloud too. And so Irving Langmuir is very excited about his new technologies developed at GE with his colleagues. And there's one lady at GE, Kathleen Blodgett, who's a prominent scientist but not well known nowadays. And she basically says she learns about these cloud-busting, cloud rain-making techniques. And she basically says to him, Irving, you can intervene in a cloud, but you can't point it downwind. You can't tell it what to do. And what we often do, I think, is confuse intervention in nature with control. How easy it is to intervene and make a little bit of I can chew up a cloud with the airplane propellers. You can fly through it and bust the cloud, but that doesn't mean you've controlled it. You've simply intervened in it, in kind of a Baconian, damaging, torturing way for nature. So Langmuir's out there with his enthusiasm, and the military's running a seeding round on Hurricane King. And this actually shows they expected to seed the cloud and have it go out to sea. And then they were going to have a press conference about how they had reduced the storm winds and they had moved the storm off to but it turned around and went on into Savannah, Georgia, and made a landfall. It killed one person and caused immense damages, and they canceled their press conference. And this is a case in which GE and their scientists and a Nobel Prize winner had gone way too fast, way too far to try to control a Hurricane King. That the GE people had gone with the military rather than with their own corporation to try to get their seeding techniques weaponized, to try to get the military to control clouds. You might think, yeah, control clouds, but to load the clouds with radiological, biological, chemical agents and have them precipitate on will, while beating the Russians to the same game. So there was actually a weather race with the Soviets in the 1960s, 50s and 60s, just like there was a space race in the 50s. And when you open up Colliers, you get the seeding planes going out. Imagine maybe it's over Eastern Europe or the eastern part of Western Europe. And the planes are going off and they drop their seeding balloons with timed fuses and go back to base. So they're safely home. The ideal of the Air Force is to get their pilots back home without any casualties. So they drop their seeding balloons. The seeding balloons explode and their agents fall down on these happy little cumulus clouds on the right side. Panel 2, the little happy cumulus clouds get kind of bigger. They're seeded, so they get angry, turning into cumulonimbus thunderclouds on the right, and becoming a precipitating event with lightning. If you zoom in on the right panel, which I did and sort of blew it up, you see that the lead tank is getting hit by the lightning coming in across the plains. So this was imaginative. This was in Collier's, an imagination of how the military might use cloud seeding for their advantage. And everybody knows the weather kind of goes from west to east. So we are on the western side, and we could attack eastern people preferentially in this scenario. It's worth going to the library to look up Collier's and just look at this article. The invading force neutralized, according to the article. And this is Eisenhower's weather advisor. So any number of people, General George Sarnoff and some of the Vladimir Zworykin, the founder of television, all these people are sounding off in the press and in public about perfect understanding, perfect control of the weather in using these new technologies. So one of the stories of weather control is dry ice and these chemicals that you could put into the clouds. The other story of weather control is perfect forecast that might come out of an ENIAC kind of machine. So one of the important technologies that informs today's geoengineers is the computer model. All of climate, some scholars argue, can be understood by digital modeling. Oh, except the part about your comfort zone and your culture and your understanding of what's right about the world. All the social stuff you can't put in the computer. But here's a picture of a number of people. I only introduced two for now because they're two of my people I'm working on. On the far left is Harry Wexler, head of research at the Weather Bureau, who is literally von Neumann's right-hand man. And this is as he was the person that really helped get this off the ground from the Weather Bureau side of things. And then there's Johnny von Neumann, the famous mathematician. And these men and their team, a lot of Scandinavians and a lot of really smart mathematicians, said, what do we do with a digital computer? What would you do? Last weekend, I was at a meeting, and a guy that wrote a book about computing said he was at a meeting at Lawrence Livermore a week before. And they came to him and they said, what would you do if you had a computer that was 1,000 times faster than anything that exists right now? And they wanted to brainstorm at Lawrence Livermore. Well, these guys, Mockley, the computer pioneers from Philadelphia, came down to the Weather Bureau in 1945 as the war was ending. They said, basically, what would you do with a machine that's 1,000 times faster than what we have right now? So the same experiment came up. And what they did was they decided to make a digital model of the atmosphere and run it to see if they could predict the weather, and then a few years later to make these models that could indicate the general circulation of the climate system. Von Neumann was at the center of this, and so were these people in the image here. Von Neumann knew that climate engineering would need certain things, like you'd have to have at least a sensitivity model, if not a predictive model, to see what your tinkering would do to a model Earth, because you can only have one Earth to experiment on. You don't have like a lot of Drosophila Earths or laboratory rat Earths or anything like that. You only have one. And then he also thought that you probably would need something like a bully pulpit, like a satellite looking down, something that could give you a big view, a panoptic integrated view. So what are the two main technologies of modern meteorology? Computers and satellites. As soon as they were coming on board, the geoengineers start speculating. This is part of the prehistory of geoengineering. And what does von Neumann say about surviving technology? Nuclear warfare may be awful, but we may get something equally awful, which is global climate control, if it's possible. All of our present international relations may seem simple if we're controlling each other's climate. Don't deceive yourself. Once these things become actual technologies, they will be exploited. So even climate prediction, perfect climate prediction would lead to economic chaos, because you would be able to, the country that could do that could trump their competitors on the orange juice futures or something, you know. So it's really something to imagine that you could control the weather. And this is out of his famous essay, Can We Control Technology? Can We Survive Technology? The other guy in the picture, Wexler, went on to do all kinds of things to modernize modern meteorology. But he was here negotiating what's called the World Weather Watch with Viktor Bogoyev in Geneva. And I picked this picture because of the rocket exhaust. Before early satellite era too, but they were doing a lot of sounding rockets, and they were leaving their exhaust behind in places like the stratosphere. And so Wexler began to worry that all this exhaust might have a cumulative effect on a very thin layer that's really quite stable. And so I used this picture to indicate that he was getting worried about climate engineering through leaving things like chlorine and bromine, or purposely putting chlorine and bromine into the stratosphere. This is his handwriting. Ultraviolet light decomposes the ozone molecule into atomic oxygen in the presence of a halogen like bromine or chlorine. And then the atomic goes to molecular oxygen and so prevents ozone from forming. Now then there's a line, right? Can you see it in the back? Then there's a line that says, this is the bromine bomb line. 100,000 tons of bromine could theoretically prevent, he actually wrote prevert, all ozone north of 65 from forming. What country has a lot of people about 65 north and, you know, so, and Wexler was one of the advisors to Kennedy's best and brightest, and he actually warned the military that this could be done. That this could be done with a couple rockets full of bromine, and a catalytic reaction could destroy the ozone layer. That, to me, folks, is geoengineering. This is a warning about it, not the actual practice of it. But it was in their minds and in their models and in their satellite world of '62 that this kind of technique could be done. And actually, this is about 10 years before the Nobel Prize winning reactions were written down about ozone depletion. And so this is one of the reasons, you know, you only whoop out loud once or twice in your life in the Library of Congress reading room. And when I found this letter, it was like, wow. And then all the librarians came over and says, are you okay? Or should we kick you out? Or do you need a doctor? But it was really neat. And I've shown it to a lot of ozone people. And they're not just amazed, but they want to understand more about the history of it. And so Wexler then, with his models, early models, and early satellite results, gives a warning about climate control being merely an interesting hypothetical exercise. I think that's where we're at right now. And that was where we were at in '62. And I don't think we've gone much further. Until the consequences of tampering can be assessed. And most schemes have such colossal engineering feats. The Russians were talking about damming the Bering Straits and changing the flow of Russian rivers, and we were talking about all kinds of things. And there was speculation about shifting the Gulf Stream on purpose. But then there was also nuclear weapons and used as geoengineering devices. And this is another legacy of Teller. And so these irremediable harm to the planet side effects, this is kind of where the conversation is now, only a mere, I mean, I don't even know how many years that is, almost 50 years later. I'm doing this for a friend who's here because there was an actual geoengineering attempt. I'm starting to use James Van Allen's participation, not his experiment, but his participation in an experiment to measure nukes in space, which is an actual modification of our globe. So when people say geoengineering's never been tried and we're the first generation to try it, you'll hear the current people say that quite a bit. I'll just say, well, you haven't read about our actual modification of the Van Allen belts. Now, not many people, even at professional meetings, know what the first instrument in space was, launched by our US Explorer 1 and other satellites. It was a Geiger counter. And Van Allen had a lifelong interest in sending Geiger counters to high altitude with different techniques, but he finally got the big rockets in the satellite. And the first Explorer from the US had a Geiger counter, so did Explorer 3, and they were able to identify the magnetosphere. This is one of his colleagues, Ernie Ray at University of Iowa. Note, 1958 Gamma, that's Explorer 3. Space is radioactive. Now, there's a new metaphor for you. Space, the final frontier. Space, the vast unknown. Space, our next home. Space is radioactive. I think it's a wonderful tagline to this Explorer story, because what they were proposing to do was they didn't just discover Van Allen belts full of charged particles from the sun, but on the day that Van Allen announced this discovery to the National Academy, which was May 1st, 1958, right down the street, the day he announced it, that afternoon, he agreed to join Project Argus with the military to monitor the big A-bomb blasts that were going to create artificial belts. Now, he called it a space experiment. He wrote about it as an experiment. He actually used an IGY satellite and gives credit to the IGY, International Geophysical Year. He gives credit to the civilian effort to study the planet, but he also gives credit to the Air Force Missile Command and to the Atomic Energy Commission and to his group, which he was always Navy or Navy Reserve. And so Project Argus was more than an experiment. It was a proposal by Nicholas Christophilus from Lawrence Berkeley Labs. He's kind of like, he's my mini teller. He's like Teller Light in this case, because what he's saying right now, and I can almost hear him say it in the photograph, is the Earth, which is the center of that picture there on the blackboard, has magnetic lines. We've known that since William Gilbert back in the Scientific Revolution. But we didn't know they were full of radioactive particles till Van Allen had his Explorer. And even before that, this picture was taken before Explorer. From theoretical reasoning, Christophilus is saying, if you, lower right, if you shoot a bomb off over the Indian Ocean, the electrons will spiral, the beta particles will spiral along lines of magnetic force and re-enter the atmosphere somewhere over Moscow. He was trying to make a hemispheric death ray, or an EMP ray, that would interrupt radio communications in times of a crisis. He was thinking of killing incoming ordnance by making a big blast in space rather than having their ordnance blast us on Earth. He was thinking of killing cosmonauts, or whoever was out there trying to get us. Space was not only radioactive, it was meant to be militarized for US advantage. The Soviets had the corollary, space is radioactive. They knew that too. It's meant to be militarized for Soviet purposes. And so we had a massive number of space tests peaking in October 62. What else happened in October 62? The Cuban Missile Crisis. And so we were saber rattling in space, and somehow, and this is part of the thing I'm working on now, is stepping back to the Nuclear Test Ban Treaty. So these things are important to me. This is Project Starfish Primes, a photograph from Hawaii of the lights shining and the lights lighting up. We did a thing on National Public Radio about bombs in space around the 4th of July this year. It was the largest fireworks in the world. But these also burned out all the traffic lights in Honolulu from the EMP. And we get newspaper reports about whether the astronauts could survive passage through this, because 62 is also John Glenn's orbiting. They were worried about dead astronauts passing through the artificial Van Allen belts, and the Reds denouncing us, and the radio astronomers in England worrying about us. And then there's this wonderful phrase from 63 called predicting space weather. If you read the modern literature, you'd say space weather was invented in 2003, but the term is here in the literature as a predicting space environment in 63. Finally, the New Yorker almost always gets it right with the cartoons and jabbing at this. This is a 62 cartoon, says, well, how do you know destroying the inner Van Allen belt will create havoc until you try it? And there is the will try anything experimentation sense up there. So I'm going to wrap it up really soon, but I wanted to bring you back to policy, because this is the Wilson Center. And as I said, when I got my book, I thought it was not only tragicomic, but it was tragic-comedy connected with public policy. And Bernard Lovell, the astronomer, radio astronomer, informing the UK government in 63, no country shall take any action that would cause a major disturbance of the natural environment of the Earth, without prior consultation, of course, but this is 63. And then the NMOD treaty that I only mentioned in passing, but we did some serious work on NMOD when I was here at Wilson, and we'd like to go back to it. The NMOD is the UN Convention on Environmental Modification banning hostile use of environmental mod, like Agent Orange, or attacks on rice paddies, food supply attacks, or the CIA was cloud seeding with silver iodide over Ho Chi Minh Trail. But NMOD 78, which was ratified, prohibits environmental modification, but in there that says through the deliberate manipulation of natural processes, not just cloud seeding, but the dynamics, the composition, the structure of the Earth, the biota, the lithosphere, the hydrosphere and atmosphere, or of outer space. So it's very, very comprehensive treaty if it was revisited with enough teeth to apply it to geoengineering experiments gone awry. And there's been, and my assistant discovered 2 meetings of the parties since '78. One that tried to reduce the thresholds, it didn't quite work, and one during the first Gulf War that expanded ENMOD to cover herbicides and the kind of low-tech interventions like the oil fires, where Saddam was trying to torch the things with a theory that this might cause nuclear winter, but didn't work out that way. It was a regional smoke pall, but there was intent. Now, the question is, do we have any treaties or do we need a new treaty if geoengineering goes awry? This is just a wrap up. I think you got the idea. At MIT, I was in a panel talking about can we do it, should we try, last fall. And they had this as their logo. This was their meeting flyer, a male hand in nowhere in space controlling the planet's temperature. The temperature is being set back in this image to a setting that's 5 degrees colder than the Earth's average temperature, which to me is like an oops. There's a little subtle oops in the picture. And as you look deeply into there's southwest US and Mexico is in the middle of the thermostat. I have a high res if you want to look at it, but there's Roswell, New Mexico right in the middle, which is my metaphor for what these guys are doing. So I would just end with that and ask you, shall we fix the sky? Is it broken? And if it is broken, shall we have people with military hardware shooting at it? I'll leave it at that. Sit down here.
Well, thank you very much, Jim. As usual, your excellent mix of well-researched history, but told in a fashion that both informs and entertains. So thank you very much. I'm going to take the prerogative of the chair and ask the kind of first questions, and then we'll open it up to the floor. But ask you a question or two. So you ended with this policy context and some of these multilateral environmental agreements. In terms of how you testified on these issues in Congress earlier this year, how do you see this larger appreciation for the history being a real part of this political discussion as the appeal of geoengineering rises, in part as countries and peoples understand that the steps around mitigating carbon to address climate change is hard and difficult, and as a political enterprise, an economic enterprise, technological enterprise, this is becoming a larger point of discussion. Do you see this historical context really at the table in those discussions?
I wish. I was there on one occasion when I brought it, and there's a few of us, I think mostly ethicists also. But as I said earlier in the talk, I'd like to say any of you working in fields such as history, sociology, informed philosophical thoughts, the things we call science studies, technology studies, I'd like to have a lot of colleagues to keep hammering. Jeff told me, I said, how do you get these issues through on the public policy noises? Keep hammering it, keep hammering it. It's one of the messages of the trying to get through. So I about a year ago, I went down to Congressman Gordon's Science and Technology committee in the House. And Friday this week, I'm supposed to answer questions for the Government Accountability Office. But because all of the voices that they're getting, almost all, are coming from technocrats. So I'm not going to say that one off is enough. We just have to keep trying. It's starting to open up that we, or at least getting listened to, but we need more voices in there. The Slate magazine, which is kind of shallow and irreverent, but it's they try to be cutting edge. There's about 8 articles in the September 23, 24 Slate. And some of them are pretty well informed, I think. So we're not alone. There's a couple other books out on geoengineering from more journalistic perspectives. But I'm prejudiced towards history and the kind of the depth that when you see humans doing these things in 1842, or when you see Greek myth addressing the issues of today, it's pretty powerful. And if we could just get more people with more training and more background in there, I'd be very happy.
Well, hopefully they will take advantage and read your book. Thank you, Jim. Well, why don't we open the floor up for questions? I ask that you just let us know who you are and pose your question, and Jim will take a crack at it. So if we could start over here.
Hi, my name's Hugh M. I'm from Pacific Northwest National Laboratory, and I don't do any experiments. Couldn't you argue that we are already in violation of those treaties and conducting a massive, uncontrolled experiment with the climate, and have for centuries, millennia? You know, humankind have always modified the climate. So what do you do if you get to that tipping point? Now, your point is very well taken that we probably don't have the politics. We don't have the politics to mitigate our greenhouse gas emissions as is, and we probably don't have the politics to control experiments with trying to reverse it. But what do? You just take your lumps, it's your fault, you messed up the planet, just die.
Well put. He's referring to some theories about William Ruddiman's early agriculture helped to shape our carbon budgets, and people like Gilbert Plass way before Roger Avell warning about the uncontrolled planetary experiment that's inadvertent. It used to be called inadvertent climate change. So I doubt if we're going to indict anybody for the inadvertent stuff. And then 6.5 billion people doing 6.5 billion things that become defined to be unsustainable gradually is, to me, not geoengineering. And I've heard other scholars in the GMO, genetically modified organisms tradition, trying to defend radical GMOs as our brave new world future, and saying, well, look, we've been hybridizing corn for millennia. It's just a little bit more accelerated, a little faster. Okay, well, all right, we couldn't put a flounder gene into a tomato before, but it's just a little more of the same. And I don't think geoengineering is the same as a gradual implementation or a gradual, inadvertent experiment. Now that we know that clean air is better than dirty air, and that keeping fossil reserves is a good thing rather than burning them up quickly, I argue in the book that we should accelerate and agree to convene on this, converge on this middle path of efficiency, greater mitigation, accelerated mitigation, and also accelerated adaptation to climate change. I don't see yet, and I know the sinking Titanic, they should have had lifeboats, but the metaphors fall short for me that a sulfate cannon is going to be a lifeboat for anybody. I think it's going to disturb a lot more people than it saves. I don't think we're going extinct. And I refer to my colleague Mike Hume's book, Why We Disagree About Climate Change. And if climate change can be projected linearly, then you have rising sea levels flooding New York. But you're not doing a linear projection of social adaptation or human resilience either. The Dutch faced greater issues. And one of my colleagues in science studies says, I guess now we're all more Dutch. And the environmental movement even wouldn't accept the ideas of adaptation so clearly about 5 years ago, but they're starting to think much more about it. MoMA has this exhibit on drowned Manhattan. You're starting to visualize it in National Geographic. I think social change, and this is one of my older theses, that in climate change issues, the history of climate ideas and social responses to climate is much more dramatic and much more dynamic than the pace of climate itself. And I'll try to give you a hook on that. If you go back 100 years, you have a few degrees, have 0.7 of a degree cooler on average than it is now, according to the IPCC. 100 years ago, what did you have here in what is this place called? Metro, no, it's not Metro Center.
Oh, Federal Triangle?
What was in Federal Triangle 100 years ago? Okay, so it was getting close to that time when there was a swamp and sheep and stuff in the White House. And so on decades to centuries time scales, the pace of intellectual and social change is much greater and more dynamic than the actual climate change, unless you have an asteroid impact. And so it behooves the atmospheric scientist to study what I call science dynamics, which is, to me, the history of science. And if you put that in perspective, and the big word now is not just adaptation, but it's resilience. So I'm going to put my bets on resilience and human learning and social learning and the kinds of things we can do to switch our energy economy worldwide. And a group that does this in DC talks a lot about the Climate Institute down at the Heinz Center now. So I admire that kind of discussion. I think that's sustainable and that's discussable. But the Lawrence Livermore boys with their toys popping off disadvantaged solar radiation, Plan B, and all of that is they're so metaphoric that and potentially dangerous without the social dimension.
Okay. Bill Mansfield there in the middle.
Bill Mansfield with the United Nations Environment Program. Given the fact that these techniques can now be employed and can be done by countries and even individuals, as you say, and it is a new international problem, isn't the next public policy step to bring together at a national level and international level individuals to develop rules of control that will monitor the research and make it transparent and find ways to control the experiments before they get out of hand and the individuals and the governments act unilaterally?
I think we agree on that. I told the Congress that give the billions to the atmospheric scientists for better understanding, but give us a little bit to work with the policy meetings without the airplanes, the people to talk to each other, but from all disciplines, because I would hate to have simply one discipline represented at the policy table because of the perspectives that you get, that I've gotten and been rewarded by from my fellows in other disciplines. So I'm in agreement with you. I think we could do it quickly, we could do it cheaply, we could do it without any experimentation around various tables that reach higher and higher levels. And if we don't do it, then what we're going to get is possibly the lack of transparency, the announcement that somebody's done it.
Bill, can I put it back to you, since you are working with the UN Environment Program? Is that an area of effort that UNEP is looking to provide that convening role as they have on so many environmentally related negotiations?
It is an effort that we are trying to get our people to address. And so the work that's being done in the U.S. House of Representatives and the UK Royal Academies, we are bringing that to their attention with the hopes that we could pick it up. We are one of the logical international organizations that could pick it up, but we haven't gotten there yet, and we're working on it. Thanks.
Okay. Thank you. Thank you very much. Yes, ma'am, down here.
I'm Barb Karn from EPA, and let me give you some words that maybe you haven't caught yet. Sustainability on steroids. I wrote a short blog on geoengineering, but I wanted to ask you if in researching your book, you also found historical evidence for the ocean fertilization aspects.
Very good question. Yes, I have a section on OIF, as they call it, ocean iron fertilization. And it turns out the basic theory came out of a Colby chemistry grad, John Martin, who had polio and worked on, went to Moss Landing Marine Laboratory and came up with the idea that iron was a limiting nutrient in plankton growth. But he did most of his experiments in bottles. So you take a bottle of ocean water and make sure that you're not contaminating with something else. And as you add iron to it, the plankton could bloom. It's called a bottle experiment. Then the oceanographers went to the patch level, because they were thinking that at least in ice age times, the extra dust blowing off the Sahara or places like that would give you a natural iron dose that would give you patches of algae blooming. So they went out to try to build a natural patch or an artificial patch using iron chelates and pouring things into the ocean with some tracers in them. And so the ocean community is some of them were quite excited about learning about the ocean and its currents and its biosphere through ocean iron fertilization experiments. But then about 5 years ago, maybe plus or minus, when I was here too, there were groups that were named Planktos and Climos and Green Seas and companies that wanted to commercialize this when there was still a carbon trading going on in Chicago. They wanted to make the oceans work for them. They wanted to reap a harvest for their investors. And so I've captured some of their old websites where it says you don't have to be an oceanographer to understand that what we're doing is just simple fertilization. and then we're monitoring it with these high-tech satellites that look at chlorophyll. So it's like low-tech science with high-tech monitoring and a great investment. And they were selling portfolio stuff. Some of them did. Some of them were more or less rogue. They wanted to fly not or sail not under U.S. flag, but under foreign flags. And one of them was off being chased by people like Greenpeace and things. So it was really quite an episode where it looked like these geo or large-scale engineers were going out to do what they were going to do anyway. And I was at a meeting. I got invited to a meeting at Woods Hole by Ken Bussler, who was organizing the oceanographic community. There's a great issue of Oceanus, a popular magazine out of Woods Hole, and it's about 2006 or 7. And it covers, at an introductory level, it covers this whole issue of iron fertilization, which is another one of those let's accelerate nature so that we can, in the commercial sense, reap the harvest. There's a genre like that. I subscribe to a geophysical magazine called EOS by the American Geophysical Union, and one of the covers said, dumping carbons into the deep ocean trenches was the title of the talk. And I just scratched my head when I got the magazine. It says, we don't know anything about the deep ocean trenches, or at least we don't know enough. And to dump our waste into another biosphere that's several thousand meters down is just doesn't seem right. Even if we knew about it, we discovered all that new life on the black smokers and all that stuff. So it's about our attitudes to nature. This is almost like environmental studies on steroids, Earth system science, thinking about planetary more than landscape properties. Environmental history is often about a place, but we have a planet, and it's very hard to say these kind of ethical things about the planet. But when you do it, I think it's a very powerful thing. So thank you for reminding me of OIF. There's a little bit in the book, but I refer you to Oceana's special edition, if you'd like to.
Well, we're about at the time, so we can leave it at that. Jim, we thank you for your eloquence on these issues, your obvious digging deep into the archives. If you're having eureka moments in the Library of Congress, that's an excellent sign that you're doing due diligence on getting to the bottom of these questions. I do think that Fixing the Sky and the work that you're doing is a critical perspective that has not been reflected yet well enough in the broader discussions, but is absolutely a shining example of what Wilson Center is supposed to be doing, which is giving folks like yourselves the opportunity to come to Washington and do the research and set it in the historical context that provides the critical backstory that is part of the front page story of policy issues that we're debating today. So we thank you very much for coming and sharing with us today.
Thank you.